Investigating Resistive Forces Lab, Group 4B. The research question that we chose to investigate was, how does the viscosity of a fluid affect the velocity of objects falling through it? We hypothesized that more viscous fluids would cause objects moving through it to have a lower velocity. We found that the fluids with more viscosity applied a stronger force to the beads moving through it, which caused them to have a slower velocity when compared to the beads moving through water, which had a much higher velocity. We used multiple models to explain our findings during the experiment. First, we used a system schema. The metal ball eventually became in contact with the graduated cylinder. The fluid in the first trial was water, and in the second trial was corn syrup. We also made a free body diagram. There's a resistive force being applied upwards on the ball, and there is the force of gravity being applied downward on the ball being dropped in the fluid.
For this lab, we did 2 trials in total, one trial for the corn syrup and the other for water. For both liquids, we dropped a metal ball bearing to them and recorded the activity on video. This up-close view gave us the opportunity to see what exactly was happening to the ball bearings in our liquids. Our independent variable was the type of liquids we used, and our dependent variable was the change in the velocity of the metal ball bearings. The metal ball bearings in the 50 milliliter graduated cylinder remained our controls.
The data displayed here was collected using the tracker program on our video of the metal ball falling through water. For simplicity's sake, the velocity downward is regarded as positive, while any acceleration that would lower the ball's velocity from point to point is shown as negative. It is clear from the velocity versus time graph on the left that the ball slows as it falls through water, and this is confirmed by the acceleration graph on the right, which shows that the ball was decelerating for the most part. The same rules regarding the first set of data for water also apply to the set of data gathered for the metal ball falling through corn syrup, which is displayed right here. The data presents a clear trend downward with regards to velocity versus time on the left, and after about 1.7 seconds, the acceleration due to time presents very little change until the end when the ball completely stops on the bottom.
Our resistive force we were focusing on in this lab was viscosity. We learned from our readings that as an object moves in a fluid, either a liquid or a gas, it drags bits of the fluid with it along its surface. Viscosity is the overall internal friction in that fluid. We can observe the difference in viscosity demonstrated by dropping the ball bearing in our liquids. The ball bearing moved quicker through the water due to the higher flow rate of water than the corn syrup. We ultimately observed a higher velocity value for water and a lower velocity for the corn syrup because corn syrup was more viscous than water. Overall, viscosity is similar to macroscopic friction because if you have a fluid flow around any object, in our case the metal ball bearings, all of the friction is produced in a very small area around that object called the boundary layer. That layer shows a strong gradient between the velocity of the fluid on the top of the object and the outer edge of the boundary layer. Based on this gradient, the higher the viscosity, the higher the friction the object will experience.
There are a variety of errors that could be due to the human factor in our experiment, such as the balls not being dropped from precisely the same height. This could lead to a greater initial velocity and therefore skewed data when looking at how long it took the balls to fall comparatively. Other various errors could result from simple misclicks in tracker, but those were purged from the final data sets.
Thanks for watching!